diving into the area part, okay, where we're looking at area between a curve and axis. Okay, so just a diagram understanding. Okay, so whatever curve that we have, if it's bounded, okay, by A and B, and we're looking at this particular area over here, where this curve has the function y equals to mx. If you're looking for the area A, so let's say this is area A, okay, it can be found by integrating from A to B. Integrating what? We integrate the function of the curve with respect to x if it is in terms of x. Okay, so that is how we find the area under the curve. You're given this diagram. Okay, we have the function y equals to 4 over x squared, and we want to first find out what is the area of the region A. So applying this concept over here, to find the area of the region A, we will have to integrate from 2 to 4. Okay, integrate the function 4 over x squared with respect to x. Okay. In other words, we are looking at integrating 4x to the power negative 2 with respect to x. Hence, we will get 4x power negative 1 over negative 1 because power plus 1. Okay, with the values 2 to 4. Okay. Upon substitution of the values, we find that the area would actually be 1 unit square. So because we're trying to find out area, there should be units, okay, and the unit in a generic sense will be unit square. And then in part 2, we want to find the value of K such that the area of B is half of that of the area of A. So in other words, we're forming an equation that looks like this. Okay, so we have to form an equation based on its integrals. So area of B itself is bounded by 4 to K. So we are integrating from 4 to K. Okay, 4 over x squared x equals to half times the area of A, which we have already found, and that is 1. Right, so we need to find the value of K, and we can only do so by integrating this first. Okay, integrating 4x squared actually we already know, and that is 4 over x. Oh, sorry, negative 4 over x. Okay, with the boundaries 4 to K equals to half. And then we substitute in the values. So K first, negative 4 over K, minus away negative 4 over 4 equals to half. Okay, then we get a simpler equation for us to actually solve. Okay, and we find that k is equals to 8. Given this function y equals to square root a square minus x square, they have given you a diagram. Okay, they ask you to consider the graph and find out, okay, what is the integral from 0 to a of this particular function in terms of a and pi. Okay, before you get yourself too enthusiastic and try to solve this question, we need to observe that we actually do not have the abilities to integrate this function. Okay, why? Because the inside of this is not linear. Okay, we can only integrate when it is a linear function like ax plus b to the power of something, okay, where that something is not negative 1. Right? Okay, so we only have the skills to actually integrate this. So we don't have the skills to integrate this, then the problem is, then how? Okay, how are we supposed to even find out what is this? Alright, so which explains why the question asks you to consider the graph itself. Okay, so what do we observe from the graph? Okay, what kind of shape do you observe from the graph? It's a semicircle, right? Okay, and in a semicircle, we are able to actually find out the area of a semicircle because we know pi r squared gives us the area of the full circle. Okay, but in this circle itself, okay, maybe let's translate this equation that has been given to us. So we are given y equals to square root a squared minus x squared, which actually is the same as y squared equals to a squared minus x squared. Then hopefully you realize that there is this form that we find familiar, which is y squared plus x squared equals to a squared, or if you need a little bit of help, it is actually x squared plus y squared equals to a squared, whereby our center is 0, 0. Okay, the center coordinates is 0, 0, and the radius is a. Okay, because our equation of a circle is x minus a bracket square plus y minus b bracket square equals to r square. Okay, so by comparing our generic equation of circle with this one, okay, the center is actually 0, and then the radius is actually a. So we are able to tell that, okay, if center is 0, 0, radius is a, that means down here will actually be a. And what this integral tells us is to integrate this particular function from 0 to a. So we are bounded by the line 0, x equals to 0, and the line x equals to a. So we are looking at this area itself. Okay, so we're not looking at the entire semicircle. but only this quarter circle. Okay? So to determine the integral, 0 a square root a square minus x squared x. That also means that it's the area of the quarter circle. So that is 1/4 of your pi r squared, whereby your radius is a, so pi a squared. Okay, and that leaves us with 1/4 pi a squared. So in fact, we're not doing any integration in this question. Okay, we're just trying to draw the relationship between area under the curve with a definite integral. Questions for that? Try 6. Let's take a look at try 7, okay? In try 7, we have a diagram showing part of the curve of y equals to e to the power negative x. We are given that the area bounded by the curve, so let's pay attention to the phrasing because you must understand the phrasing in order to determine what is the area that is being described. Don't expect that the diagram given to you will always provide with you the shaded area already. Okay? So it says that the area bounded by the curve y equals to e to the power negative x, the x-axis, and the lines x equals to 0 and x equals to a. This area itself is actually half unit square. Question wants you to find out the value of a. Okay, so following the way that it is being bounded by the curve. Okay, followed by the x-axis, and then followed by the lines x equals to 0 and x equals to a. This is where you need to know that x equals to 0 is a vertical line, likewise x equals to a is a vertical line. So we are looking at this area actually. Okay, and this area, by using our integration, the integral we're looking at is from 0 to a, okay, and then e to the power negative x dx. Right? And the question has told us that the area is half unit square, so we can form our equation. Okay, of the integral equals to half. And then we proceed with integrating. So integrating e to the power negative x keeps it the same, but not forgetting to divide by the coefficient of x with the boundary 0 to a equals to half. And then we substitute in the values. Okay, so the negative is due to this one, then x is equals to a, followed by minus away, not forgetting the negative, x equals to 0. Here we get e to the power negative a equals to negative half. Our question wants us to find the value of a, so need to apply logarithms. A ln E. Ln E is actually 1. So negative A equals to ln half. Okay, in other words, A equals to negative ln half. Okay, you may leave your answer in this manner. Okay, but I know that your answer in your textbook is slightly different. That is because ln half is the same as ln 1 minus ln 2. Ln 1 is actually 0. Hence, we get a positive ln 2.